Self-driving vehicles. Beginner level. Introduction. Self-driving vehicles, also called autonomous vehicles, are cars that can drive themselves using artificial intelligence, AI, without human control. These vehicles use advanced technologies to detect roads and lanes, identify obstacles and pedestrians, follow traffic rules, make driving decisions, navigate to destinations. Examples of self-driving technology are being developed by companies like Tesla, Google, Waymo, and others. Self-driving vehicles are one of the most exciting applications of AI in the real world. They combine multiple technologies such as machine learning, computer vision, sensors, lidar, radar, cameras, GPS and navigation systems, decision-making algorithms. What is a self-driving vehicle? A self-driving vehicle is a car that can operate automatically using AI systems and sensors. In simple words, self-driving vehicle equals a smart car that can drive itself without a human driver. A basic autonomous system can detect surroundings, understand the environment, make decisions, control the vehicle. Why self-driving vehicles are important? Driving involves many challenges such as human errors, accidents, traffic congestion, fatigue and distraction. Self-driving vehicles aim to solve these problems. They help checkmark reduce accidents, checkmark improve road safety, checkmark save time, checkmark assist disabled or elderly people, checkmark optimize traffic flow, checkmark reduce human workload. Levels of vehicle automation. Self-driving vehicles are classified into levels 0 to 5. Level description. Level 0 no automation. Level 1 driver assistance, cruise control. Level 2 partial automation, lane assist plus braking. Level 3 conditional automation. Level 4 high automation, limited environments. Level 5 fully autonomous, no driver needed. Key components of self-driving vehicles. Component purpose. Cameras detect lanes, signs, objects. Lidar measure distance using lasers. Radar detect objects and speed. GPS provide location. AI models make decisions. Control system operate steering, brakes, speed. Example of sensor data. Self-driving systems use real-time data like vehicle_state equals speed 50, lane, center, obstacle_distance 20, traffic_light, green, closing curly bracket. This helps the AI understand the current situation. Simple self-driving decision example. Obstacle_distance equals 10. If obstacle_distance less than 15, print, brake immediately, else, print, continue driving. This is a simplified version of how autonomous systems make decisions. How self-driving vehicles work. Step 1. Perception. See the environment. The vehicle uses sensors and cameras to observe surroundings. Example. Lane_detected equals true. Pedestrian_detected equals false. AI processes images and sensor data to understand the road. Step 2. Localization. Know position. The vehicle determines its exact location using GPS and maps. Example. Current_location equals highway. This helps in navigation. Step 3. Planning. Decide what to do. AI decides the best action. Example. If pedestrian_detected, print, stop vehicle. Step 4. Control. Execute action. The vehicle controls steering, speed, and braking. Example. Speed equals 60. If speed greater than 50, print, reduce speed. Eye and lane detection. Lane detection helps vehicles stay within lanes. Example. Lane_position equals left. If lane_position equals center. Print. Adjust steering to center. I in obstacle detection. AI identifies objects such as vehicles, pedestrians, animals, roadblocks. Example. Obstacle equals true. If obstacle. Print. Stop or change lane. I in traffic sign recognition. AI reads road signs using computer vision. Example. Traffic underscore sign equals stop. If traffic underscore sign equals stop. Print. Stop vehicle. I in navigation. Self-driving vehicles use AI-defined routes. Example. Routes equals Route A, 30. Route B, 20. Closing curly bracket. Best underscore route equals min. Routes. Key equals routes.get. Print. Take. Quote. Best underscore route. Full menu-based self-driving simulation. Python. Def obstacle underscore detection. Distance equals int. Input. Enter obstacle distance. Quote. If distance less than 15. Print. Break. Quote. Else. Print. Safe to move. Def lane underscore control. Position equals input. Enter lane position. Left, center, right. Quote. If position equals center. Print. Adjust steering. Else. Print. Lane stable. Def traffic underscore sign. Sign equals input. Enter traffic sign. Stop, go. Quote. If sign equals stop. Print. Stopping vehicle. Else. Print. Continue driving. Def speed underscore control. Speed equals int. Input. Enter speed. Quote. If speed greater than 60. Print. Reduce speed. Else. Print. Speed OK. While true. Print. N1. Obstacle detection. Print. 2. Lane control. Print. 3. Traffic sign recognition. Print. 4. Speed control. Print. 5. Exit. Choice equals input. Enter choice. Quote. If choice equals 1. Obstacle underscore detection. L if choice equals 2. Lane underscore control. L if choice equals 3. Traffic underscore sign. L if choice equals 4. Speed underscore control. L if choice equals 5. Break. Else. Print. Invalid option. This simulates key functions of a self-driving vehicle. Concepts learned from this topic. Learning self-driving vehicles helps beginners understand. Checkmark computer vision basics. Checkmark sensor-based systems. Checkmark real-time decision-making. Checkmark automation and control systems. Checkmark I in robotics. Checkmark safety systems. Real-life analogy. A self-driving car is like a human driver who sees the road, understands traffic rules, makes decisions, controls the car. The difference is that AI does this using data and algorithms instead of human judgment. Ways to improve this project. You can enhance this project by adding real-time camera input, object detection using AI models, lane detection using OpenCV, GPS-based navigation, reinforcement learning simulation, self-driving car game simulation, integration with sensors, IoT, deep learning models, common mistakes beginners make. Crossmark thinking self-driving cars are fully perfect. Crossmark ignoring safety and edge cases. Crossmark not understanding sensor importance. Crossmark assuming AI works without data. Crossmark oversimplifying real-world complexity. Where self-driving vehicles are used. Self-driving technology is used in autonomous cars, delivery robots, self-driving trucks, warehouse robots, agricultural vehicles, public transport systems. Advanced systems also include driver monitoring, predictive braking, adaptive cruise control, automated parking. Simple definition. Self-driving vehicle. A vehicle that uses artificial intelligence and sensors to drive automatically without human control. Final summary. Self-driving vehicles are one of the most advanced applications of AI. They help beginners learn. Checkmark AI decision systems. Checkmark computer vision. Checkmark automation. Checkmark real-time processing. Checkmark robotics concepts. They represent the future of transportation and smart mobility.